Hello and welcome to this second lesson. My name is Alexander Votyakov and today's topic is fractions, multiplication and division. I am a math and computer science and economics teacher from Russia, and I have a lot of Russian subscribers on Russian YouTube channels, and I'm just starting this English spoken channel that I'm going to use to teach you mathematics. I hope for a very long and productive relationship between us. During the next few years, you are going to see me way more than you see your friends or your parents, because you're going to dive deep into mathematics with me on this YouTube channel, and you're going to watch a lot of videos, because math for you is going to become the favorite subject. It's going to be super easy, it's going to be super understandable. So let's move on to the fractions. You have probably watched the previous lesson where we have discussed what fraction is and how to add and how to subtract different fractions, and how can you reduce the fraction or vice versa, multiply the numerator and denominator of the fraction by the same number to get a bigger fraction, seemingly bigger, but actually it's going to be just the same fraction. And then how you can add two fractions that have different denominators. Like this is 3/6 plus 2/6, 6, so it's 5/6. All this was covered in the previous lesson on fractions. Today we are going to get acquainted with multiplication and division of fractions. So let's go on and let's take a fraction and multiply it by some number. For example, 3/7 we will multiply by an integer number 2. We will multiply two fractions a little bit later. Right now we have to learn how to multiply some fraction by the integer number. Yeah, this is a cucumber Rick. I forgot to introduce him. He is watching you. Whenever I'm turning my back on you, he is not. He is watching you, that you are watching the video and still attentive and so on. So don't mind him. We have this 7th. I hate 7. That's my least favorite denominator. Well, let's do this. 2, 3, 4, 5, 6, 7. Let's say that's a little bit off the mark, but anyway. So I have 7 parts, and we have 3 of them. 1, 2, 3, 4, 5, 6. That's 6 parts. Now we have 7. We have 3 out of 7, and when you multiply 3 parts, 3 pieces by 2, 3/7 by 2 means that you have to take 3 more, and you're going to have 3 plus 3. So it's basically the same as adding up 2 numbers. Multiplying by 2 is just adding 2 of the same numbers, and we already know how to do that. That's 3 plus 3, 7. So it's 6/7. Actually, what I did was multiply the numerator by 2. So 3/7 multiplied by 2 is 3 times 2, 7. And this is 6/7. That's a pretty straightforward rule, isn't it? Take a look at this. 5/18 multiplied by 2 actually equals 5 times 2, 18th. So it is 10/18. If you have watched the previous video closely, then you know how to reduce this fraction by 2. 5 and 9. So we have 5/9. That's it. Let's do another one. 3 9 multiplied by 3. This is going to be 3 times 3 divided by 9. So it is 9/9. And then you reduce it and you get 1/1. And this is just 1/1. So it's 1. It's like 1 piece of pie divided by 1 parts, and that's it. That's just the total 1 piece of pie. Let's move on and learn how to multiply the other way around. I will try to multiply an integer number by a fraction. For example, I will multiply 3 times 1/7. This means I want to take a 7th part from 3. 7th is a bit of a not too comfortable a number for this operation, but what if I want to take a 6th part out of 3? Let's say I want to take a 6th part. Yeah, 6 is good. I have 3 whole pies. That's the number 3 here. and I want to multiply it by 1/6. So this means I want to take like not a half, not a third, not a quarter of, but I want to take a 6th part. So I want to divide 3 pieces of pie into 6 parts, and into 6 parts, and I want to take one of these 6 parts. That's pretty easy to do. I just divide it like that, and I have 6 parts, and I take 1/6. So it's going to be half of the whole pie. So it is a half. But how do you like turn it into a rule? How to do this systemically? How to, I don't know, how to remember it? How to use it in terms of mathematics, like in class? You can just do this. 3 times 1/6 is the same as 1/6 times 3. So what you do is just multiply your denominator by 3, and you get 1 times 3, 6. So it is 3/6. And then you reduce the fraction, and you have 1/2, and that's it. That's a half. So now we know what to do. When you multiply a fraction by a number, like in any order, you just multiply the denominator of the fraction by the number that you are using, and that's it. That's what you have, and you reduce the fraction if necessary, but all in all, it's just like that. Okay, let's move on to the other topic, as in we are going to learn how to multiply 2 fractions together. Or let's first take a little bit of a side tour into the world of irregular fractions. I believe they're called irregular in English. In Russian, it's just the same as irregular. Like 7/3. How much is that? That's a weird fraction because the denominator is bigger than the denominator. It is called irregular for that reason. If you have a pie that is divided in 3 parts, how can you take 7 of these parts? You take 1, 2, 3. Where do you get the 4th? Well, you have to draw another pie, and you have to divide it in 3 parts too. So we have 1, 2, 3, 4, 5, 6, and still not enough. You have to take another pie, and you have to divide it in 3 parts, and you have 1, 2, 3, 4, 5, 6, 7. That's it. 7/3 is the same as taking 2 whole pies and another third. This is called a mixed fraction. I believe in English. I don't really know the correct term in English. I'm right, but no, probably not. So it's 2 whole pies, like an integer number 2, and then plus, you don't write the plus, you just write it like this, 2 and a third, and another third of the pie you add to the 2 whole pies. How do you transfer the fraction from the irregular form into the mixed form? It's called mixed because it is a fraction and an integer, like mixed fraction integer form, something like that. So what I have here is 7/3, meaning that we have like 6 plus 1/3. So we have 6 pieces that are divided by 3, and another third piece, 1/3 piece. And 6/3 is 2 total pies. 2 whole pies. And what you have here is 2 and a third. That's how you do that. That's how you turn irregular fraction into a mixed fraction. Why did I take this detour? Because I wanted to show you how you can multiply some fractions and get irregular fractions as a result. For example, 2/3 multiplied by 5 would equal 10/3, which is an irregular fraction. So what you're getting here is like 10 divided by 3 equals 3, and the remainder is 1. Yeah, I just did that. 10 divided by 3 equals 3, and remainder equals 1. So we have 3 whole pies and 1 piece left that is not divided by 3. So we have to keep writing it like it's 1/3. If you imagine 10 pieces of thirds, then you have 1/3, another 3 parts, 3, and then you have like look a little bit like a face, right? Like these are the eyes, and this is like, whoa, you are learning math, aren't you? That's nice. So we have 3 pieces and 3 more pieces and 3 more pieces. That's 9, and then you have 1 more piece. That's 10. So altogether we have 3 here, 3 here, 3 here, and then another one. Then we have 10 pieces out of like 10 thirds. This means that we have 3 whole pies and 1/3. This is very often happening from multiplication, because when you multiply by big numbers, you're getting a big nominator without the denominator changing. Please note that while we are multiplying a fraction by a number, by some integer number, we are only multiplying nominator of the fraction. We are not multiplying the denominator. If we did that mistakenly, for example, 2/3 times 5, what if we multiplied both nominator and denominator? We would get 10/15, which is actually, after reducing, becomes 2/3 again, as if we have not done any multiplication at all. So this is a mistake. When you are multiplying nominator and denominator together, you are not changing the fraction at all. And you want to change it. When you multiply something by 5, you want to make it 5 times bigger. If you multiply nominator and denominator by 5, you have not changed the fraction at all. You have not made it 5 times bigger. You have just remained, like, the fraction remained the same. You did not change it. So this is wrong. That's why I'm going to wipe it off the whiteboard. Let's move on. What we have here is the multiplication. Now let's learn how to multiply two fractions together. When you are multiplying a number by a fraction, you are taking this part of the number. For example, if I want to take half of 7, I would say either 7 divided by 2, this is like 3.5, for ones of you who know the decimal fractions, but usually I would write it like 7 halves, right? 7 divided by 2 is 7 divided by 2, so it's 3 whole pies and 1/2. But what if I want to like take another approach? I would like to earn, to find half of the 7 by multiplying 7, taking 1/2 of the 7. When you multiply 7 by 2, you get like twice the amount of, like, for example, you have 7 apples, and your friend also has 7 apples. How many apples do you have altogether? 7 multiplied by 2, right? When you're multiplying 7 by 3, you're like 3 friends have 7 apples. And when you're multiplying 7 by 1/2, what is the meaning of it? Like, you have 7 apples, and then you have to take the amount of apples and multiply it not by 2, not by 3, but by half. You're trying to halve the amount of, like, multiply by half. It's just the same as halving, meaning taking less, taking 50% less, taking like two times less. This would mean that you're taking 3.5. 3.5 is like that, 3.5. This is exactly half of 7. When you're dividing 7 by 2, you're getting like 3 more. Like, you have 7 pieces, and this is half of 7, and this is also half of 7, and they are both 3.5, right? So divided by 2 or multiplied by 1/2, it's the same. So when you are multiplying by a half, you are taking half of that. So that's the same as division by 2. Or it is also the same as writing the denominator beneath the number you are trying to do. Like 7 times 1/2, 1 second, is 7 seconds. That's it. How do we work with that from here on? Let's try multiplying two fractions together and learn how that works. I will use some simple fractions, not too big, not too small, just to, I don't know, just practice with them. Let's say I want to use the fractions that have non-trivial nominators and denominators. For example, 2/3, I'm going to multiply it by, let's say, 4/5. How does it work? Well, first I will explain the rule. Then I will explain how you can look at that from different angles, because this is really not so easy to, I don't know, to imagine yourself. Like, all the previous things that I have explained were very easy to come up by yourself. You could like imagine fractions yourself. You can create them from scratch. You just could like sit at your table, think really hard, and you would imagine that fractions probably exist. And you would understand how you can add them up, or how you can subtract fractions, and how you do all these other operations. Like, you could do this without any textbook and without any teacher. You could probably think up the fractions yourself, like a true mathematician would. Mathematicians, mathematicians of the past, like Euclid, like Euler, Pythagorean, like all these different names that you're probably not familiar with yet, they have all created mathematics themselves. They have imagined things, understood things, proven things, and created math. Like, actually, they did not create it, they just realized that it works like this. They realized that the numbers, they like tend to go on together with like these rules and so on and so forth. Like, nobody really creates mathematics. Mathematics just exists, and we merely open our minds up to mathematics, and mathematics comes into our mind, and we're like, wow, that's cool. And what I am doing here is explaining things to you, so you understand them better, so you understand math. And what I urge you to do is, instead of just learning math the traditional way, like you used to, like you're listening to my lecture and you're like, okay, this works like this is pretty clear, this is understandable, and so on. I urge you to doubt my every word, whatever I'm saying. Like, imagine I'm the biggest liar of all, and I'm trying to, like, yeah, that's hard to imagine because I'm a teacher and you're a student, and how can you accuse your teacher of lying? But imagine I am a liar, and imagine I'm not trustworthy. So whatever I tell things that I'm telling you, this works like this. And you have to doubt my words, and you have to try and understand, why does it work like this? Is it really the best way for fractions to work like this? Like, when I'm telling you the definitions, you don't have to doubt my words. The definitions are always like, the definition is the thing that I'm just telling you that this is called fraction. Okay, like the definition of a fraction is, imagine a pi, imagine the division, and so on. But when you're learning things from me, I want you to not to learn them from me, but to learn them by yourself. I want you to figure that out by yourself. Let me just be the guide that guides you through this world of mathematics, that gives you the tasks, and I just want to watch you progress through these tasks. I want you to solve them by yourself. I want you to figure out how it all works by yourself, under my scrutiny, under my guidance. So this is how this process is going to go. I'm going to explain things to you, of course I am, like, these are lectures and lessons and so on. But while I am explaining, I want you to think hard on whatever I'm explaining to you, okay? Okay, that's the deal. So the first thing I'm going to do is, like, no explanations, just the rule. 2 times 4, 3 times 5. I hate it when teachers do it like this. When you want to multiply two fractions, you have to multiply nominators and multiply denominators. That's just how it works, kids. Just remember that stuff, and, well, yeah, that's how it's gonna go. Well, actually, it is how it works, but it's not too clear why does it work like that. So it is 8 15, but why does it work like that? Why is it correct? Why multiplying a fraction by a fraction is like this way? Let's try a different example. Let's see. For example, I want to have the 8 9th multiplied by a half. So this would mean that I'm taking a half of 8. 8 9th is, divide your pi into 3 parts, and then 3 more on each part. So that's 9th. 1 2 3 4 5 6 7 8 9. Right. 8 9th is almost the whole pi, except for one little piece. That's 8 9th. And when you're multiplying it by half, you're taking a half of that, like cover the half, and you have 4 9th. The answer would be 4 9th. But if I follow this procedure, I'm going to get 8 times 1, 9 times 2, and this would be 8 18th, which is not 4 9th, is it? Actually, it is. When you reduce this fraction, you get 4/9. That's exactly what you get, 4/9. So it's the same somehow, like your intuitive understanding of how halving works, it's just halving of the denominator, is actually consistent with the rule I just gave you. So that's nice, right? Nice to understand. Well, how else can we like take a look at that from a different angle? Maybe we can try another option, another number. Let's say, what is the rule for multiplying 2/3 by a 5? What you are doing is you're just multiplying 2 and a 5. Like, remember that rule? That's 2 times 5 thirds, right? So it's 10/3. But what if you look at the number 5 in a different way? Actually, number 5 is also a fraction with 5 as the denominator and 1 as the denominator. So if you take 1 whole pie or a cake and you divide it into one piece, so the whole pie is the whole piece. Then you have 5 whole pieces of pie. This is 5 ones. It's the same as 5 whole pieces, right? So if you look at this like that, you are going to see that instead of multiplying by 5, we are actually multiplying by 5 ones. So it's 2 times 5 in the denominator and 3 times 1 in the denominator. So this rule that we have previously understood and proven and like kind of enabled ourselves to use later, this rule is also consistent with this weird new rule of multiplying nominators and multiplying denominators. So what I want you to do for the next few fractions is just to memorize this rule, that you have to multiply nominators and multiply denominators, and just keep in mind that it is consistent with a few other, with your other understandings of how fractions work. But in general, you are going to understand it a little bit later when we will explain like more things to you, like division and so on. And let's move on to division, actual division. When you divide your fraction by 2, for example, you have to take half of what you have. So you're going to have 1/3. So division works pretty much the same as multiplication. You have to divide the top number by the divisible, like the top number divisible by the divisor. Yeah, that's a divisor. Yeah, you have to divide the divisible by the divisor to understand the denominator of divisible fraction by the divisor to get the answer. So when you divide 2/3 by 2, it's 2 divided by 2/3. What do you do when the denominator is not divisible by the number you're trying to divide by? Division is pretty much the same as multiplication by a fraction. Dividing by 5 could also be written as dividing by 5, or more like 2/3 multiplied by 1/5. Division by 5 is like taking a fifth of the number. Let's try 15 divided by 5. This is 3. 15 times 1/5. This is 15/5. So it is also 3 because it's the same. Dividing is the same as multiplying by the fraction that is turned upside down. When you have 5, it is the same as 5 ones. When you turn it upside down, you get 1/5. So number turned upside down is the fraction with this number in the denominator. Dividing by the number is the same as multiplying by the number that is turned upside down. And this is where the fun begins. Because when we want to divide one fraction on the other fraction, it is like really simple. All you have to do to divide 2/3 by, like, let's say 5/7, you just have to turn this fraction upside down and do the multiplication. That's it. That's the rule. And we already know how to do the multiplication, right? It's 2 times 7 divided by 3 times 5. Okay, what we have here is 14 divided by 15. Nice one. That's almost a whole cake, but like missing one piece, 1/15th piece. Okay, so now we know the rules. Let's practice a little, because on the first lesson we did not really practice much because we did not have much time left, but here we can practice a lot because we already know how the multiplication works, how the division works, how everything works, and now we are going to practice. Alrighty, how do we practice? I'm going to write down some set of examples, set of problems. They're not going to be like too hard problems, and you can pause the video and you can solve each problem in your own time, and then you can like keep playing the video and see how I am going to approach this problem. Let's take a few easy ones. They're all going to be on the addition or subtraction of various fractions. I'm going to need more space, so sorry. The first one is 2/7 plus 3/7. Second one is, if you already know the answer, that one, good for you. Skip to the next part, maybe like use the scrolling of the video to move between parts and so on. Let's say 3/8 plus 2/8. Let's take some 15/17 minus 13/17. Let's spice it up a little. 1/5 plus 2/8. How do you do that? You can reduce the second fraction, right? 3/8 minus, let's say 1/7. How do you work with that? Okay, the 6th one would be 8/15 minus 3/5. 7th one would be 9/10 times 2. The 8th one would be 3 multiplied by 5/6. How much are we going to get? 9th is going to be multiplication of two fractions. It's going to be 2/11 times 121/4. And the 10th is going to be division of two fractions. It's 3/4 divided by 3 seconds. This one is irregular, but we don't really care. It's a division, so it works very similarly to what we discussed before. Okay, so 10 tasks. You can do them in your own time. It's probably going to take you somewhere around 5 to 10 minutes. Probably most of the viewers, if you were like really smart, you have already figured out the answers to all these tasks just while I was writing them. But well, I'm going to explain them to you now anyway. If you are really smart, you can just skip to the next part where we're gonna do some harder things, and let's move on. 2/7 plus 3/7 is obviously 2 plus 3/7. So we're having 5/7, and that's it. That's the answer. Because 7 is the same denominator, so when we are adding two fractions together, we keep the denominator and we add their nominators together, so we get 5/7. Here, it's just the same problem. We get 8 as the denominator and 3 plus 2 as the nominators, so we're having 5/8, and that's the answer. Here we have the same denominator, meaning that we have to keep the denominator, and nominators are 15 minus 13, so we're having 2/17. Here we have different denominators. What do we do with that? 5 and 8. 5 times 8 equals 40. So we have to turn these fractions into fractions with the 40 as the denominator. Let's work on that. 1/5 equals some denominator and 40 as denominator. How did we do that? We multiplied 5 by 8 to get 40. So we have to multiply 1 by 8 to get 8 as the denominator. So the first number equals to 8/40 plus, how many is 2/8? 2/8 equals some denominator 40. How do we get 40? We multiply 8 by 5. So we have to multiply 2 by 5 too. So what we're getting is 10/40. 10/40 it is then. and then we add them up together. So we're getting 18/40. This could be the answer, but 18/40 is a reducible fraction. So what we have to do is we have to reduce it. 18 is divisible by 2, and 40 is also divisible by 2, so it's 9/20. That's it. That's 9/20. The answer is 9/20. That's the fourth task for you. There we go. What about the next one? 3/8 minus 1/7. How much is that? Yeah, actually, I could solve fourth like way faster if I reduced the second fraction faster, because it's not 2/8, it's actually 1/4. So the numbers are smaller, and we have to get it to 20. 1/5 can be multiplied by 4, numerator and denominator, and we're going to get 20 as the denominator and 4 as the denominator. Plus 1/4 can be multiplied by 5, because we can get 20 as the denominator and 1 times 5, 5 as denominator. And the answer would be 9/20. That's like way faster, right? Because you first reduce the second fraction and then you do the addition. That's faster. Okay, what about the fifth one? 3/8 minus 1/7. We have to turn them into the fraction with the same denominator. What is the denominator? 8 times 7 is 56. So we have to multiply this fraction by 7, numerator and denominator. And this fraction has to be like anti-reduced multiplied by 8, numerator and denominator. And we're getting 21 minus 8 divided by 56. That's it. 21 is gotten from 3 times 7, and 8 is 1 times 8, and minus is from here. 8 times 7 is 56, is the denominator of this fraction, so it's 13 divided by 56. That's it. 13/56. And this fraction is not reducible, because 56 is only divisible by 7 and 8, and all the divisors of 8. So it's 2, 4, and 8. That's it. And 13 is a prime number. Primes are numbers that are not divisible by anything except for themselves and the number 1. 13 is divisible by 1 and by 13, so that constitutes it as a prime number, which means that 13 is not divisible by anything that 56 is divisible by. So this fraction is not reducible. Okay. Let's move on to the next one. 8/15 minus 3/5. Well, that's kind of simple, right? We just multiply this fraction, denominator and denominator, by 3. Thus, we're not changing the fraction, right? We're just like changing the view form of this fraction. We're taking 8/15 minus 9/15. Oh no! We have gotten a negative number. Well, probably you are familiar with negatives already, right? So I'm not going to surprise you too much when I say that negative fractions also exist. They mean like the depth, or like the temperature is rising minus, like rising by a degree, or like dropping a degree, like a minus degree or minus half a degree or something like that. So that's kind of understandable anyway, right? Negatives are just the way of understanding something reducing even lower than 0. 0 is like nothing, and negatives are like even worse than nothing. Like you can have no money, or you can have no money and a big loan from the bank that you have taken previously and just have not paid out yet. So you have like your financial situation is even worse than 0, because not only you don't have any money, you also owe some money to the bank, which means that if you are getting some money from somewhere and then you pay it to the bank, then and only then you're going to get 0. So right now you have some weird amount of money that if you add 1 million to, for example, you're going to like still have 0. This means your amount of money right now is negative. That's how you perceive negative numbers. But yeah, probably you already know all that. So 9/10 times 2 is 18/10, because I'm just multiplying 9 by 2. And 18/10 is reducible by 2, so it's 9/5. 9/5 or 9/5, probably 9/5. And this is an irregular fraction, so you can't leave it like that. You have to take the whole number out of it. 9 pieces out of 5. This means that there is one whole cake and 4 more pieces. That's it. 3 times 5 sixths. That's 3 times 5 divided by 6. That probably I'm gonna have to count like 15 sixths and then reduce it by 3. So it's 5 and 2 and then 5 seconds, and then I have to like do the like mixed fraction out of this irregular fraction. But I'm not gonna do this. I'm going to reduce it right here. Take a look at that. I see that this number is going to be divisible by 3 because this number is 3 times something, meaning that it is divisible by 3. And this number is also divisible by 3. So I'm reducing it like that. I'm just crossing out the 3, and I'm dividing this number by 3 too. So it's 5 seconds. Yeah, see? 6 is actually a 3 times 2. So when I'm crossing 3's, I'm doing the reduction. I'm getting 5 2's from here on. Like, I have just spared myself one multiplication operation. I'm so lazy, like very lazy for a mathematician. I hate doing extra work. I don't want to multiply 3 by 5. I don't want to get 15 and then like do the reduction and so on. I'm just doing the reduction right here before the multiplying. I see that the number is going to be divisible by 3, so I'm dividing it by 3 right away, and I'm getting 5, obviously, because 3 times 5 divided by 3 is going to go back to 5. And what I'm having here is 6 divisible by 3, so I'm dividing it by 3 and getting 2, so 5 seconds is 2 whole cakes and 1/2. That's it. Let's work on this one. That's the multiplication, so it's 2 times 121 and 11 times 4. What we're having is the number that is going to be very big, but I am going to reduce it right away, right here. So 2 is divisible by 2, and 4 is also divisible by 2. I'm going to have 2 left. Probably I'm going to use another marker for reductions so that it will be clearer to understand. Here I'm getting 1 because, well, 2 divided by 2 is 1, 4 divided by 2 is 2. 121 is divisible by 11, if you remember your multiplication table, right? And then you can divide 11 by 11, and you're getting 1. Sorry, I have to use the red marker. You're getting 1. And you can divide 121 by 11, and you're getting 11. That's it. We're having 1 times 11 divided by 1 times 2. So we're getting 11 seconds, 11 halves. And this is 5 whole cakes and 1/2. And after all this time, we are finally getting to the point. We can divide 3/4 by 3 seconds, 3/2. I don't know how to say it, so yeah. Excuse me, my English is not too good. Excusez-moi, por favor. My English. Yeah, well, I know Russian though. I can like explain all that stuff in Russian to you in perfect Russian anyway. But yeah, I'm not going to. Also, I can do English with Russian accent if you want to. If you want to, I can speak with a Russian accent if it makes my English more understandable. I am going to do this do this in Russian accent because well, this is what I do best. I speak Russian accent in English. With I don't care about like rules, grammar. Grammar is I don't really know grammar because I don't care. So I'm going to speak English with Russian accent for the remainder. Yeah. Also, I have to have this like golden chain or like some other symbols of like a typical Russian accented guy, right? So 3/4 divided by 3 is halves. How much is that? It's like 3/4 times 2/3. Yeah, don't get me wrong. I love my country very much and I love people in it. So I'm just like mocking my own accent because I don't know. That's what I do. 3/4 times 2/3 is 3 times 2, 4 times 3. How much am I gonna get? 3 times 2, 4 times 2. I don't really want to multiply them again. I just want to, I don't know, like do it like right here. 3 are the same numbers. 2 and 4 also. Like this is 1 and this is 2. So it's 1/2 and that's it. So we have destroyed this fraction. Like totally. We just did this problem and we destroyed it. We won and it lost. That was a good battle, guys, right? Like that was nice. That's it. I think we are done for today. The lesson is pretty long enough. So this is Fractions-2. I'll call it like that. And we will proceed to the next lesson. It is also going to be about fractions, but I will touch on the decimal fractions and the percents too. I think probably these are going to be different lessons, but yeah, anyway. So yeah, I want you to subscribe to the channel to not miss out on the next videos, and also, well, have fun and well, love math. And below there are some links to the various ways to learn mathematics with me. If you're watching this like a few months from now on, probably you're going to see many links already, because I'm gonna create a lot of mathematical courses in English, and you can learn math with me, and it's gonna be good. It's gonna be good. Yeah. See you around on the next lesson. Goodbye.